Okay, we are back. We've got a question on hypothesis testing with the normal distribution. So here it is, question number 1. We've got the height of kangaroos, h meters, is found to be normally distributed with a standard deviation of 0.3 meters. Now it's thought that the mean height of a kangaroo is 1.9 meters. A random sample of 20 kangaroos is taken and the mean height is actually found to be 2.09 meters. And what we've got to do is test at the 5% level of significance whether the mean height of kangaroos is actually bigger or greater than 1.9 meters. So there we go. There's lots of information to take in. Jot some of this down, have a go at the question, and we'll catch up in a couple of seconds to go through the answer. Righto, it is solution time. So the first thing we should do before we actually begin with the question is look at our distributions. Now you're used to seeing a normal distribution like this, where you've got your mean, your standard deviation squared. However, when you take a sample, what you need to do is create a new distribution for the sample mean. And so that's where you need to begin with all of these questions. So we'll say here that the height of the kangaroos is normally distributed with a mean of 1.9 and a standard deviation of 0.3. However, now what we need to do is turn that into a distribution here for our sample mean. And so we'll say h bar is normally distributed with the same mean 1.9. However, we've got to change our standard deviation here. And to do that, here's our formula there. We take our old standard deviation, we divide it by the square root of our sample size, n. So that's going to be 20 in our case. So we'll have 0.3 over the square root of 20. And then we'll just put a squared outside there. And there it is. We've got our distribution. Now we're ready to start solving our problem. Next, we need to put out some hypotheses. So what's our null hypothesis? So H0 is we're going to assume that the mean is indeed 1.9. However, the alternate hypothesis is that the mean is actually greater than 1.9, right? That's what we're testing. So mean is greater than 1.9. Okay, cool. So we've got this. This is great. Next, what I'm going to do, I'm going to make a sketch. So we've got to draw this out, right? And there it is. So we've got our normal distribution. We've got our bell-shaped curve. Our mean, we've said, is 1.9 supposedly. And our significance level for our test is 5%. And so what we're looking for is whether or not the result of our sample mean is going to be in the top 5% or not, right? So I'm going to say this area here represents the top 0.05%. And so what I need to do is work out whether 2.9 meters falls within this 5% or outside of this 5%. And now there's a couple of different ways obviously to solve this problem. I'm going to do it this way. I'm going to look for the probability that the sample mean here is going to be greater than 2.09. And so how can I do that? Well, all I need to do is open up my calculator, go to my distributions, and find the normal CD. Now our lower value, because we're looking for greater than 2.09, our lower value is 2.09. Our upper value can be anything big, we'll use 10,000. And our standard deviation, remember that there is now 0.3 divided by the square root of 20. And our mean is 1.9. Okay, there we go. So what we've got now is that the probability of being greater than 2.09 is 2.31 times 10 to the minus 3. So obviously a very, very small number. That there is 0.00231. And so what can we tell? Well, we can tell that 2.09 must be around here somewhere, because the area to the right of it, greater than it, is really small. It's just 0.00231, which is definitely smaller than 0.05. So we can say that 2.09 is definitely within our critical region. So let's put it as this. We can say 0.00231 is smaller than 0.05. And what that means is that we can reject RH0. So let's put maybe reject H0, cross that one out. And what we'll need to do now is accept RH1, which is our alternate hypothesis there. So what have we found out? We found out that there's enough evidence to say that the mean of these kangaroos is in fact greater than 1.9 meters. Now, as I mentioned, there is two ways to solve these kinds of problems. That's just one of the ways, right? So what we did is actually look for the probability that it was greater than 2.09. The other thing we could do is this. So let me just do some rubbing out. Let's get rid of all this info here and this info here, and we'll get rid of this and the 2.09. I'll just rub this out here real quickly and just put the tail back in. There we go. Okay, so the other thing we could actually do is work out our critical values or critical value, which is going to be this here, which is like the cutoff for the top 5%. And so how can we actually work out what this value here is? I'm just going to call it, I don't know, let's call it A for now. So to work out this value, we need to remember that we could use the inverse normal function. Why? Because the area to the left-hand side of A, if we think about it, is just going to be 0.95 because the area to the right of it was 0.05. So I'm going to label this here 0.95. And so what we could do, as I said, is use the inverse normal, option number 3. The area is 0.95 to the left of it. Our standard deviation, that's going to be 0.3 divided by the square root of 20. And our mean is 1.9. And so if we have a look there, that tells us that our critical value, so where everything changes, is basically 2.01. And now what we do is, well, look at the mean that was actually found in our sample, which was 2.09. And what you can tell is 2.09 is definitely on the right-hand side of that. There it is, 2.09. And so what we can see is it's in our critical region. And because it's in our critical region, what do we say? Well, the same thing again. We reject H0, cross that one out, and we accept H1. And so we get to the same conclusion, right? Two different ways, use whichever one is better for you. And there's our hypothesis test done. So hopefully you've learned two different ways there to solve any of these hypothesis testing questions, and make sure you remember what I said about the distribution. Always start with creating a distribution there for your sample mean. Another question coming real soon, so stay tuned and I hope to catch you in another video.